Okay, welcome everybody. My name is Deniz. I'm a software architect at MotionSpell, and today I'll be presenting our work on our findings on the subsegment representations effect on Dash and the live streaming experience. So today I'll start with what is subsegment representations and why is it important. Then move on to how do we package it, play it, and finally share some of our ideas on why there are some trade-offs and potentially challenges. So to begin with, we saw around 94% improvement in the pre-roll buffering. So there are some benefits to this approach, along with some drawbacks as well. So what is SSR, subsegment representations? So they are a way to represent Dash segments in smaller chunks. So usually in the manifest, it's represented as an additional adaptation set, and it's aligned with the segment boundaries of the regular Dash segments. And they are important because it allows fast switching and fast tuning of features. Because since we have smaller chunks and each chunk starts with the IDR, you are able to switch to another adaptation set much more quickly than just waiting for the next segment boundary. So, and also for VOD applications, it offers much more fine-grained seeking, again, because of the much more granular chunks. And it's also segment compatible with LLHLS. So if you're already packaging for LLHLS, you don't need to do repackaging. You can just use the same files, but just modify the manifest. They are mainly used in live streaming sports, live sports streaming, and potentially any application that require live latency, like minimum target latency. Because you can tune in much more faster. You are able to view the stream much more faster. But I guess the important part of this feature is that with content-aware ABR algorithms, you are able to adapt to the content much more quickly. For example, in a football match, if there's an important segment coming up, you can just switch to a lower quality adaptation set if you suspect a stall or buffering is coming up. This is potential right now, but we plan on exploring this idea as well. And for interactive live events, if you want many more people to participate in an ongoing event, having a fast tuning offers much more opportunity for much more people to participate in that current event. So, packaging SSR for L3D Dash. L3D is low latency, low delay Dash. How does it work? So there are two key changes to the Dash manifest. They are pretty simple. So adapting to it should be very straightforward. First of all, segment structuring. As I mentioned previously, each media segment must be divided into partial segments. And these partial segments should be accessible via byte ranges or as an individual files. And each of these partial segments must start with a random access point so that they can be used without any previous frames. And the manifest just requires an additional adaptation set with proper essential and supplemental properties in order to reference other adaptation set on which stream to tune in after the tuning is complete. The adaptation set for the tuning requires the segment template name to include subnumber and the K property. K property means how many parts there should be for each segment. And using these two information, the player can correctly derive which parts to fetch and how to fetch them. So configuration is done with GPack. It's capable of packaging for L3D Dash. And the command line, I'm just going to go briefly on it, just so you can use it yourself as well. So we have a live source. It's a simple AVGN counter. you also have the capability to use like regular files and loop it. And we just need two encoding. One for regular dash or LL dash with 2 second or relatively longer GOP length. And one more for the SSR. This has a much more smaller chunk duration. Like here, it's 0.1 second. And finally, the manifest generation and segment generation. This is it for constructing the JPEG command line, and it will produce the segments and manifests that I'm going to show in the next slides. So, first of all, it generates the manifest, of course, and the segments that the manifest is referring to. So here you see the first adaptation set is the longer GOP length adaptation set. It has the only difference between the regular dash is the supplemental property that it refers to, which is the second adaptation set. That's the tune-in adaptation set. And this one refers back to the other one as well. And as you can see on the segment template, the K property and the media itself has the sub number in it. And these are the only changes required to enable the low latency, low delay. So playing it, the player has been provided to us by castLabs. So if you have any questions about the player itself, you can reach out to them. How do players handle SSR? So as I said, players benefit from fast tuning and fast switching, but they use the K and subnumber elements or the names to derive which parts to pull from the origin. And that's enough to use the second adaptation set. It's pretty similar to LLHLS in this case. And yeah. So the players will switch to much more efficient GOP adaptation sets once the tuning is complete. So that means the next on the next segment boundary. So for performance evaluations, we compared L3D with low latency dash, and we evaluated also the Cloudflare as our CDN to see if there were any potential benefits of using a CDN on top of this. And in all 4 cases, we saw similar results on the average time to first frame, which is around 560 milliseconds. But the most important part here is the pre-roll buffers. So with low latency dash, L3D dash, you don't need too much pre-roll frames, because you're already starting from IDR and can switch to the other segments, the much more efficient segment in the segment boundary. So you don't need to start from the previously rendered frames. And challenges and conclusion. So again, there are some benefits to using this approach, but of course you need to encode one more adaptation set at the same quality and for the same content. This requires, and also with much more smaller chunk durations, so with much more IDRs. And of course, with many more IDRs means much more data transfer required to tune in many concurrent users at the same time. So that's something to keep in mind as well. And extra complexity on the packager side. Although it seems a couple of changes, in some use cases this might complicate the pipeline, but honestly the specification and the manifest itself requires minimal changes. But on the player implementation, without proper implementation, without support for SSR, you'll be defaulted back to LL dash. So you won't be benefiting from SSR or L3D dash. But as long as these all are okay with you, we can benefit from all of these benefits. And conclusions. So we have successfully packaged L3D and was able to play it through both Origin and through CDN. And despite the potential benefits, it delivered on its promise to allow us to tune in much more faster and achieve the low latency, and without extra pre-roll frames. Then the next step we want to see is whether there are any potential benefits in using HTTP3 quick, and whether it's useful in this case, or maybe we are targeting something not necessary, but we'll see. We'll see in the future. We also want to thank Comcast for sponsoring the GPAC SSR implementation and our previous collaboration at the IBC as well. Thank you so much. And if you have any more information, if you have any questions, you can ask it now or just find us. Thank you.
Thank you. We have time for questions. Thank you.
Thanks, Deniz. That was very interesting. I have a question. Everyone's looking at L3- for its benefits for fast tune-in and quick switch, as you indicated. But if you go the other way up the stack, in other words, if you say I want highly efficient segments for my stable playback, if I have a client that's on fiber and it's pinned at the highest bitrate anyway, you could add 20-second or 30-second segments that have a single GOP. So now you have a very efficient upper layer for transport. Have you experimented with that side of it at all?
Not in our experiments, but I will imagine that will also benefit from the same thing. But in this SSR's case, the benefit you see is in the faster switch and faster tune-in. So the regular GOP length shouldn't really pay too much any effect here.
But longer segments save people money, and at the end of the day, the economics could actually get them to switch to this, even if they don't care so much about the tune-in, but they care about saving money for a certain quality level on their stable playback.
Yeah, as long as they match on the segment boundary, it's flexible enough.
Yes, less of a question, more of an answer to what you were asking, Will. Since we were working together with Deniz on this project, we did some experiments on larger GOP sizes for this. And yes, you're absolutely right. It does help. And there you can see an even more dramatic sort of increase in performance when it comes to the tune-in, obviously, because now you would need to download 10 seconds, 20 seconds of media before you see the first frame. So conceptually, it's totally valid. You can go to much larger GOPs, and I think what Deniz was also explaining, you are not bound to just a single SSR adaptation set. You can build ladders basically, right? So you can start with like an iframe only adaptation set, and then go to 3 frames, 10 frames, 24 frames, and sort of walk through that ladder. It's really sort of a question of how much additional data you want to put into your manifest, and then obviously into your CDN.
Yeah, there are examples on this in the specification as well for the ladders.
Oh. Thank you, Deniz. My question is regarding the audio and video segments, which are separate in fragmented MP4. In terms of GOPs, we've been discussing about the GOPs. So as packet of the audio are not aligned exactly with the packet of the video, there might be some misalignments in terms of player. The player is expecting the audio before the video and so on, and these kind of things. How did you manage that? How you overcome that in terms of GOP sizes, all this kind of, in low latency dash especially?
So in this case, we only use video to do our experiments, just to see, like conceptually, if it's working, if there are any benefits. But segment alignment should be, of course, handled with care for the audio packages as well. But in case if there's any problem with that, there could be additional adaptation sets to handle audio as well. But otherwise, the encoding should handle or ensure that the segment boundaries align properly with audio or video.
Questions? I have a couple of them.
Yeah.
Did you try -JS, which is also implementing LS3D?
I spoke with Daniel.
No, you're not? Okay.
Not yet.
Not yet. You don't do it. Oh. Okay. Second question. I'm curious about your HTTP3 remark. What do you expect here?
I mean, since there are much more smaller chunks, we hope the HTTP3 will help will mitigate the additional requests and just keep an open connection to receive the smaller chunks, the SSR chunks, much more faster. But that's a theory. We don't know how many other benefits there could be. We just need to experiment with it. It's just the next steps for us.
Okay, good. Thank you.
Thank you.
Next speaker.